Hello, everyone. Thanks for coming to this talk. Today, I'm going to talk about tracking Android app responsiveness at scale using JankStats. Well, first of all, a little introduction about me, about my company, the work I work for. I'm an Android developer at Bitdrift, a company focused on mobile observability at scale. Previously, I was working at Uber in the driver platform team, focusing a lot on performance and quality. And outside software engineering, I really love playing guitar and spending time with my kids. And this is kind of like the biggest stage I've ever been, even for a guitar. So very, very exciting to be here. OK, well, let's get into the subject, app responsiveness. This is a wide topic, right? Like, many things can define app responsiveness, and everyone knows at this point, as an Android developer, this mantra, right? Easier said than done, right? You should never block or delay the main thread. That's very easy, no? But we know it's not that easy in real time, in real situations. And there's a wide term. This is a wide term that can refer to various topics. For example, when people talk about app responsiveness, they say, OK, well, ANRs, right? The application terminated, it's not responding. Well, there's responsiveness. They talk about perceived app usability. So, for example, reacting to our input touch latency, app launch time, screen transitions, etc. Or smoothness. Or you're scrolling through a list, it's very janky to scroll. You start suddenly having jank or frame drops. It's not a great experience for the user. And Google Play has its own definition on Play Vitals, Play Console. You have this super critical metric there, user perceived ANR, which input dispatching timeout. Basically, if you are over the thresholds this, you're likely going to be penalized. Your app is not going to be as visible as other apps. Of course, there is also app start time. There's some metric there you can check on your core vitals. Slow rendering, stall frames, frozen frames, they display that information as well, and how you compare against competitor apps. And this is another one I just found yesterday, is slow sessions for games. That's a metric I haven't played personally, but that's a definition there. So using this, by the way, the user perceived ANR rate, the recommended one for Play is 0.47 of daily sessions. And another ones like this, slow rendering and frozen frames here. So how can we comply with what Google Play tells us? How can we make sure our application is responsiveness? No, it's responsive. ANRs, using this, well, an ANR, most of the people think is just the main UI thread being blocked for 5 seconds, right? There's more to that. It's not only the main thread. Oftentimes it's a service timeout, content provider, maybe not responding to binder call. There's a link here with a great explanation of how to diagnose your ANRs from the documentation itself. I recommend to check it out. But for the purpose of the talk, we're going to focus more on input dispatch timeout on the main thread. Now, we talk about perceived app usability and smoothness, and can manifest different ways. As I mentioned before, start while scrolling, laggy animations, delay screen animations, and not reacting to touch input events, which is pretty bad. Like, nothing happens to that when you do that. Terrible experience. And when the app terminates due to main thread not responding, it's already too late. We miss the opportunity to catch those not responding issues, right? Again, Google Play, if you go to the documentation, it has a definition of jump frames, of drop frames. Basically, they constitute what a slow frame is a frame that didn't render between. It takes like 60 milliseconds up to 700 milliseconds. Frozen frames, 700 to 5 seconds, and ANR frame, it's 5 seconds and up. But OK, well, what are drop frames, also known as jank? Well, a jank frame is when the render duration exceeds the expected deadline by the vsync. For example, that depends on your current frame rate. If you have a display of 60 Hz, the expected deadline should be 60.67 milliseconds. If you have a higher rate display, 120, 8.33. If you don't render a frame, that will be a drop frame. And that's pretty much, that's the Jank we are current, this dropped animation, stuff like that. Now there's more to that. There's like, we are talking about main thread, right? But main thread we know is responsible for doing all these things, on measure, on layout, input touch, events. There's also another thread that's quite important for the rendering, and it's the render thread. It's a really good name. And basically can handle all the GPU stuff. It was introduced on API 21. Maybe certain low-end devices, very old devices cannot have it. But basically, it takes away all the work for rendering from the main thread, and so the main thread can focus on the important stuff like input touch events, on measure, layout, and stuff like that. It's a visual representation of both working together. Now we know how important is main thread, render thread. How can we track this? Probably some of you have heard about the strict mode. Strict mode is a great tool in development phase. Unfortunately, this is not really suitable at scale. The purpose of this talk is how to track this at scale before it's too late, right? And to get those insights in production. Fatal ANRs, this means our terminal ANRs. Those are too late to the game, as I mentioned before. They are impacting users, and sometimes the trace that you get from Play Console is not really useful. You need to know what happened before that ANR. Another solution is custom watchdog. There's a clever solution that constantly pings in the main thread to check the responsiveness, and now you can report if you reach the threshold. But again, there is some potential overhead of doing that constantly. Macro benchmark and micro benchmark, these are great tools. I totally recommend use these pre-release, pre-shipping to production. This is awesome, but we cannot monitor at scale what's happening to a user in production. And of course, Perfero, AES Profiler, you can run this. Totally recommended, do all this, but they are more suited for local development and not for scale, at least for now. So with that, we come to JankStats and how we decide to go with JankStats for monitoring drop frames. The most important thing is a Badware compatible library. It supports pretty much, it's an awesome Jetpack library. It's very lightweight. I think when we did the study, it was like 5 kilobytes of binary size increase, which is very little. And exposes per frame performance, and is suitable for scale. A small caveat, you can see here, that's the beta in the library. But we've been testing this in production without issues. I would recommend you to try this in production. It's totally ready. And what can we do with JankStats? Well, we can monitor janky frames at scale, as I mentioned, right? We can pinpoint those frustration moments from the user. We can get visibility, and Google Play recommends to focus on these first. For example, focus first on ANR frames because they are more terminal, they are more noticeable to the user. Then later focus on frozen frames, which likely occur on app launch, maybe on screen transitions, they are more noticeable there. And then improving slow frames, especially for your first user impacting features, right? Like, and maybe you have an important list and start lagging a lot, or you want to improve that. Now let's talk about setup. There's great documentation already, but I'm gonna show some of the caveats. How you set up? Well, you need to provide an on-frame listener per the current window. This is very important, current window. Now you can create your own frame listener. And you will see there's some useful information that is passed to the volatile frame data object. There's a warning here. If you're below API 24, make sure you're not doing expensive work here, because that will run on the main thread as it's using the choreographer to detect the drop frames. API 24 and up, it uses the dedicated thing called frame metrics aggregator. Now that we have our own frame listener, we can attach to our current window. More importantly, we can control. We can say, okay, let's set the tracking, let's disable the tracking. That's very useful on their own. And the volatile frame data contents, what it has? Well, the start time of the frame, the duration values, where or not if the frame is considered jank. Right? This is the most we care about. And also a set of key value streams recorded by a holder, performance metric stakeholder, where you can attach additional metadata so you can gather where the jank is happening. This is actually very useful. This is great. If you are a small app, you can do this very easily. You have multiple activities. You can do this on many activities. But if you want to set it as a library, or you want to set more generally, you can use this approach that we did to set a more general setup. So for app launch setup, the first time the app launches, we need access to the current window. And remember, as a library, we don't have access to activity directly. It's not that easy. So what we did, we leveraged the lifecycle event observer on a state change callback, listening for on create. But we need a window at the end of the day, no? How can we get the window? Well, we inspire on Curtains library, an awesome library from Square, on pull the current window, just an inspiration from that library, and that's how we pull in it. And this is how it looks like. This is the whole lifecycle for app start. Now we should be able to have a JankStats instance running and set up from the app launch. Hey, that's great, but maybe I want to stop tracking when the activity is paused, the current activity, or when I change activities, I want to focus on a new activity, things like that. Well, in that case, I can relay another callback, which is the activity lifecycle callback. And when the activity is paused, I can stop the collection because the user is not interacting with the app. I can stop spamming logs if I don't want it, if it's not needed. I can also nullify the JankStat to prevent potential memory leaks. And on activity on resume, the activity is already resumed. You have maybe another activity. Now you are able to get that window for the most current activity, and you can set again the JankStats. Here's again the current life cycle of that, and this is the combined with both, like application start with the activity resume, activity pause. And our goal, again, we want to fix this in production. We want to make sure our users are happy and they are not experiencing bad performance. In that case, we want to have something like this. We want to be able to detect NR frames. We want to know what the user was doing on that session and surfacing those jank frames. This is an example of a timeline session that we can report. And you can see on the right there is a wireframe UI and the events flowing through. We can get the duration. We can get this category. No? This is the refresher. Google Play recommends this category, so you can focus first on the most important issues. And in order to do that category, there's a small caveat. Depending on the API level, you have a different duration. So for example, on API 31, it represents the total time spent on CPU and GPU processing. API 24, it's a render thread, non-GPU, and the UI thread, and 24 is just the UI thread because it relies on the choreographer. It's not as accurate. The last one, latest API, is way more accurate. So now we need to represent this in code, and what we do is we have an init type to represent this type of jank frames, and we can just gather the right duration here, according to the type that we have for this frame. And now we can, I mean, this is not production code here on the right, but you can get the idea. Assuming 60 Hertz, you can categorize now and return and do additional stuff, no? So now let's say we only care about NR frames. Now we can set up what we call a workflow, and we can capture all the sessions in the field that are expecting, they are seeing this behavior with NR frames. And that means we will be able to collect this. We know when that happens, and the duration. But again, we want to know more. We want to have the metadata when that occurred, no? When that issue surfaced, when which screen what we were doing at that moment. So we can rely on the performance metric state to record that additional data. It's really easy to set up, but again, when you have the window, when you set up for the first time, you can rely on that current window to set up your holder. And we expose another method for tracking screen changes. You can use that to set up your screen name. And now you have here the fragment or the view that was experiencing this NR frame. You can see it here with the whole wireframe on the right. This is the configuration fragment. And now you can start investigating production for that user, right? without having to do any local thing. More interestingly, we were talking about before ANRs, mostly fatal, it's too late to the game, all that stuff. But here, in that case, we experimented an ANR frame that lasted like 10 seconds or more. And we saw the application was able to continue. So the typical thing, you see the ANR dialog, you click on wait, okay. Luckily, it recovers. Well, it recovers, and the application is able to render. But the user may have killed the application, will have been frustrated. So that's why it's important to have this information, which is not surfaced in many places. You can check out the timelines. Another important case, like, jank can be caused by many things, right? But expensive layouts, increased memory pressure, like you're leaking memory like crazy, you will see maybe like the GCA, the garbage collector, trying to do many things. And what happens here, well, you see a memory spike on the right, now a bunch of slow and janky frames, and eventually an out of memory here. This is really interesting insight because you can apply the same for maybe a fatal ANR. If you start janky, doing jank frames or scrolling, and eventually the list cannot keep up anymore, and the application freezes. Now you can have that visibility. Now we can talk about more stuff we can do with JankStats. No? In theory, we can do aggregated data. We can do things like that. This is not production code by any means. But you can start checking, okay, well, how many frames I render, how many of those were jank, or even how many of those were frozen or NR frames, and now you can have a ratio. And now you can do things like this. You can gather insights of the most important sessions that are exhibiting this behavior or certain screens, and now you can go directly to those sessions. So pretty much, yeah, this is kind of like what we aim. We want to have visibility on the most important issues for the user, right? And okay, we'll talk about how to set up, how can we use in production to monitor at scale without issues. And Jank internals, JankStats, the internals are pretty much, they're all there. So for example, the below API 24, it relies on choreographer to discern when a jump frame is not as accurate as when you are on API 24 because it reuses the frame metrics API that is available. And frame metrics API is using the low-level code, the C++ code, the Jank tracker. This has been there forever. So pretty much this is a library that's been proved. It's been used in production. You just have an easy hook now, and you can do whatever you want with it. It's ready for scale, and you can have visibility. There are other things like, okay, well, other local tools. How many of you have used this one? This is a great tool. Again, local tool with a Android debug bridge, but it's a lot of information. You may need to use some scripts to parse the data. There's a lot of data here. This is great. But basically, it's the same idea. You can get like a percentage, a percentile. You can get how many frames were dropped or janky. Now you need to do some special calculation. Let's say I only care about NR frames per. So now you need to work on that script and do some kind of massaging the data there in order to get that. But with JankStats, you could even do that. And even if you have a CI or something you want to verify, you could test a baseline and compare against the baseline and say, okay, there's a regression now in CI for this new UI or this expected core flow. No? So that's why it's really important because you don't need to. You can run on the device that is on the field, no? So that's pretty great. And so the conclusion, just parting thoughts here, as JankStats allow us to monitor drop frames at scale, which is a great library. You can customize thresholds, heuristics. I recommend to customize in case you care certain type of frames. Maybe you care about ANRs first or frozen frames. It's very easy to integrate. As I mentioned, this very minimal APK size. We haven't found any performance issues. Again, if you do crazy stuff on the callback, don't recommend to do that. And remember, below API 24, that callback happens on the main thread. So let's not incur on more performance issue while measuring performance. That's kind of like the main motto. We don't want to incur more problems. We should be transparent, silent, and get that visibility in production. And that's it. Thank you for your time. Thank you for listening. please stop by our booth. We are by the end of exiting here. And all the code is available, is publicly available on this repo, the Capture SDK. You can check our company website. And I also wrote an article here for this integration. You can see here with a little more details. And yeah, and thanks for your time. Let me know if you have any questions. Happy to answer.